And to the product of masses, it's and
Product
inversely.
to the product of masses, and this is and
Okay.
inversely proportional to the distance between them.
Ma'am, so distance is generally like the actual distance between them or from the midpoint of the object to the other
The
one.
actual, see, generally the distance will be given to you, okay, but if you have to calculate the distance, so let's say the radius is given, this much distance is also given to you, then you have to consider the radii as well of both the objects, as well as the distance between, like this distance from here to here. So basically you have to like determine the center to center distance in order to put here in this formula. That generally will be given to you. You will be asked to calculate the force, the masses, etc. So this thing,
Excuse me, ma'am.
but if it is not, you have to consider the center to center distance. Yes.
Ma'am,
Right?
sorry, I left the meeting. I had
It's okay.
connection issues.
It's okay. So you didn't hear anything?
No, ma'am.
Okay. So while everyone is writing, I'll explain Rehat again. So Rehat, we have discussed only this one subtopic we have started. The first subtopic is Newton's law of gravitation. So just like we studied these three laws of Newton, here we are studying one more law of Newton, which tells us something about gravitation. Okay.
Ma'am,
So
I was there
let's
for
see what the
like half it. I listened half of it.
you understood what the like statement of the law. The
Yeah,
statement
ma'am.
basically says that every object in the universe is attracting every other object. Okay, I am going to discuss later that why, if every, so we are also a part of universe, right? So why is it happening that my laptop is not attracting me, or why am I not attracting the chair which is kept in front of me? I should attract, right? Because I am also an object in the universe, and the chair is also an object in the universe. So why is that not happening? We are going to discuss, but for now I want you to accept this statement that every object in the universe attracts every other object with a force, and the magnitude of the force, what is the magnitude, that also is given in the statement. The law says that force is directly proportional to the product of masses. Let's say I am talking about two objects here. One's mass is m1, other object is having a mass of m2. So the statement says that the force which is going to, the attractive force which is going to exist between these two bodies is going to be directly proportional to their masses. That is, the force is going to depend on the value of the masses of the two bodies which are involved in the attraction force. Okay, let's say there is a body A involved, and let's say there is a body B which is involved. So A body and B body both are a part of universe. They are going to attract each other, and the attractive force is going to depend upon what their masses are, the value of the masses. How is it going to depend? It is going to directly depend, it is going to be directly proportional to the product of their masses. So this is the symbol for direct proportion. So F proportional to m1 into m2. This is the first part. Second part says it is inversely proportional to the distance between them. Now what is the distance between two objects? See, whenever you are considering the distance between two objects, you have to consider the center to center distance between the objects, and that is known as r. That is the distance between these two objects. So it says that force is inversely proportional to the distance between them. So here you can say that F is inversely proportional to r square. Okay, so if we combine these two, then we are going to get, see, this is directly proportional to m1 m2 m2, so m1 m2 will come in numerator, and it is inversely proportional to r square, so it is going to be in the denominator. R square will come in the denominator.
Ma'am, so how do you know that force is directly proportional to mass and to mass?
I do not know. Newton knew. Newton just did experiments. He studied. He properly gave the proof of everything. And after whatever he has derived, this is just the result. The result says that the force depends upon, just a second. The force which is acting, the attractive force of gravity which is acting between two objects, is proportional to the product of masses. Now the derivation we are not going to do here. Even in the 12th class when we studied again the chapter gravitation, we do not know that, we do not do the derivation, because this is a law which is given by Newton, and he has given the proper derivation in whatever study he has done. So only thing we need to learn here is the statement and understand the statement, what the statement is trying to say. Now here also we have a confusion. Why are we not attracting every other object which is kept in our room? So we just need to understand the statement and apply it. Okay, derivation and all is not in the syllabus. Okay, Lavanya?
Yes, ma'am.
Okay, so as I was saying, Rehat, that if we combine these two, F is proportional to M1, M2 divided by R square. Now, in the previous chapter as well, I told you that in order to remove the sign of proportionality, all you need to do is replace it by the sign of equal to and introduce a constant on one of the sides of the equation. So here we have introduced a constant, that is G. So you can see that final equation is becoming F is equal to G M1 M2 by R square. Okay, so
Okay, ma'am.
this is the magnitude of force of gravitation. Okay, what is this? This is the value of the force which exists between two masses. If I want to calculate the value of gravitation force which is existing between me and my laptop, m1 will be the mass of the laptop, m2 will be my mass, G will be the gravitation constant, which we will see later. This is fixed value. And R square is basically the distance between me and the laptop. So if I put all these values here, I will get the value of the force which exists between me and my laptop. Okay. So similarly, if you are considering any two objects in the universe, you can calculate the force provided you know the value of the masses and the distance between them. Okay, Rahat?
Yes, ma'am. Understood.
The vector quantity. So it means you also need to determine the direction. So direction, what is the direction of this force? Where does it act? So if you have two bodies, let's say the gravitation force is acting between these two bodies, then you just need to join their centers, and the force is going to exist between the line joining their centers. This is the body A, this is the body B. Since body B is going to attract the body A, it means it is going to pull it towards itself. So which means that the force is going to be something like this. Body A will be pulled towards B. So which means that the direction of force is going to be like this, in this direction. Got it, right?
Yes, ma'am.
So
Understood.
all we need to understand is the statement, the relation between the masses, the distance, and finally the magnitude of the force, and in which direction does the force act. Okay. Now, guys, you must have studied about force in 8th class. There you studied a classification, that is, some forces are contact forces and other forces are non-contact forces.
Yeah.
Now, since gravitation force, you saw that it can act between two bodies even if those bodies are not in contact with each other, which means gravitation force is a non-contact force, right? It can
Yeah.
act between two bodies even if the bodies are not in contact with each other. Also, along with gravitation force, you saw two more non-contact forces, that is electrostatic force and the magnetic force, right? So electrostatic force, in that force you saw that, okay, if the charges are of the same type, that is, if they are positive charges, then the like charges are going to repel each other, whereas unlike charges attract each other. Similarly, in magnetic force also you saw that, okay, if the poles, there were two poles, right? North pole and the south pole. If the poles are alike, then those poles are going to repel each other. If the poles are unlike, they are one pole is north, other is south, then they are going to attract each other. So you saw that both these kinds of non-contact forces, that is electrostatic force and magnetic force, sometimes they can be attractive, other times they can be repulsive. Whereas if we talk about this non-contact force, gravitation force, then this gravitation force is always attractive. This force exists because the object possess mass. Similarly, जैसे कि electrostatic force. Why does electrostatic force exist? Electrostatic force basically exists because of the charges which the bodies possess. Similarly, gravitation force exists between two objects because of the masses that they possess. Okay, and electrostatic force and magnetic force can be repulsive as well as attractive depending upon the situation, whereas gravitation force is always attractive. Got it, guys? This is a very small point, but I just wanted to recall.
Yes,
Okay.
ma'am.
Yes, ma'am.
Now we are going to talk about this constant. What is this constant? See, this constant is denoted by capital G. Why was this constant introduced? It was introduced in order to remove the sign of proportionality in the equation F proportional to m1 m2 by r square. How do we remove the sign of proportionality? Do you guys remember? I told you that we do some
Ma'am, you
experiment in which we take the value of m1, we take some value of m2, we separate it by some known distance. So which means we know the value of m1, we know m2, we know the value of r, and we calculate the gravitation force between m1 and m2 by some instrument which can be used for calculating force. Okay, so all of this we know the value of force, we know the masses, we know the distance between them. So from here what we do is we change the value of these masses, and many a times we see that for different values of m1, m2 and r square, there is some value coming for g. Just like I told you that f is proportional to ma. So in order to remove the sign of proportionality, I said f is equal to kma. And I said that, okay, when I took the mass as 1 kg and I applied a force of 1 Newton on it, then I saw that the acceleration of the body was 1 meter per second square. So when I put this value in the equation, the value of constant came out to be 1. I kept on changing the values of mass, force, and acceleration. Similarly, here, I keep on changing the values of mass, the distance between them, and calculate the value of force. This is how I finally calculate the value of this constant, which is known as universal gravitation constant. Did you get my point that how are the values of the constants calculated?
Ma'am, I have a doubt.
Yes, ma'am.
Ma'am, can you explain once again?
Okay, I will
Yeah,
explain.
ma'am, even I
Lavanya, what
didn't
were you
understood.
asking? Lavanya, what were you asking?
Ma'am, so basically, if we take one for like mass 1 and mass 2,
Yes.
so automatically, and if we take force as 1,
No,
so
you cannot
everything
take
will be
that, right?
1.
See, you can't take, because how do you know that the force is going to be of 1 Newton?
Ma'am, then how did you take force is equal to
Because
mass?
I took the experimental values. I did not take it because I wanted to. I saw the experimental values, and that is why I put the value of force as 1 Newton in
Then
this case.
how will you do this? Like,
Then how will I do this? See,
yeah.
I will take two objects whose masses are known. I will take a constant distance. I will separate them by some constant distance. I will take an instrument which can calculate the value of force, and I will see what is the difference between m1 m2 by r square and f. What is the constant which I need to multiply on this side in order to make the force equal to m1 m2 by r k m1 m2 by r square. So whatever that constant comes out to be, I will find out what the value of that constant is.
Oh, so only when a specific experiment or
Yes,
something.
experimental values, which are found out by keeping certain values of mass, certain distance between them, and calculating the value of force. I haven't put here when I said that F is proportional to ma and F is equal to kma. I put the value of F is equal to 1 Newton for a mass of 1 kg, and the acceleration produced, let's say, is this much. So this value of F is equal to 1 Newton is experimental. I saw it from the book and then I put it. It is not something which I wanted to and randomly I have put.
Okay, ma'am. Got
Okay.
it. Thank
So
Yeah.
accordingly, the value of k came out to be 1. So guys, you had some confusion. Where should I start from? See, I told you that because of the statement which Newton gave, we have reached here. That is F proportional to m1 m2 by r square. Wait, I'm writing. We have reached here, that is F is proportional to m1 m2 by r square. In the previous chapter, I told you in order to remove the sign of proportionality, you have to introduce a constant. So here I've introduced this constant, and the formula for force have come out to be G m1 m2 by r square. Now if someone asks you that, okay, there is a mass of 1 kg, there is a mass of 2 kg, and there is a certain
Ma'am,
distance between them, calculate the gravitation force which exists between them. Now in order to calculate the
excuse me, ma'am.
gravitation force, I need to, yes.
Ma'am, this formula is only for gravitational force, right? Of the
Yes, this is
only for
only
gravitation.
for gravitation force. Yes. Okay.
Okay, ma'am.
Okay. So if someone gives you the value of masses, they give you the distance which exists between the masses, and they ask you calculate the force. So in order to calculate the force using this formula, you need to find out the value of this constant G, right? Which has been found out with the help of experiments which are done in order to calculate the value of G. And those experiments you do not need to read. The value of the constant is given by 6.67 into 10 to the power minus 11 units. What is the unit of G? That I am going to tell you. But the value which came out after doing the experiments, after keeping different values of masses, keeping them at different distances, calculating the value of force, and from there calculating the value of this G, we got the value every time we kept different values of M1, M2, and R. We got the value of G as 6.67 into 10 to the power minus 11. So we came to the conclusion that okay, the value of this constant is 6.67 into 10 to the power minus 11 and units. Okay, whatever the unit is, we are going to discuss later. But the value of G came out to be this much. So now we are fully prepared. We can easily calculate the value of force which exists between any two masses which are given to us. Because G की value हमें पता है, we also have the value of masses that would be given in the question. The distance which exists between those two masses, that also will be given to us. So we can easily calculate the force of gravitation, the force of attraction which exists between them. So that we can calculate. Now there is a name that is given to this constant, that is universal gravitation constant. Okay, I've told you two things about this constant. That is, G is known as, capital G is known as universal gravitation constant. The value of G with the help of experiments came out to be 6.67 into 10 to the power minus 11 units. These are the two things that I've discussed. Now I'm going to tell you one more thing, that this value of G is a constant. It is never going to change. It is a fixed value, whether the objects are on the earth, whether they are on Venus, whether they are on moon, it does not matter. The value of G does not change by changing the masses of the object, because it does not depend upon the mass of the object. It also does not depend upon the distance which is there between the objects. So G is a fixed value. It will always keep its value equal to 6.67 into 10 to the power minus 11, whether the object is kept on earth, whether it is in the universe, it doesn't matter. G will be fixed as 6.67 into 10 to the power minus 11. So the value of G is fixed. This is the third conclusion which I have given for G. And this much I've given. One more thing I'll tell you about G, that is the unit of G. But first of all, note it down. Okay, sequentially think about it. First thing I introduced, the statement. The statement gave us one information, that is every object in the universe attracts every other object. This is the statement. The law also gave us the force, the formula for the force. Okay, and the formula came out to be G m1 m2 by r square, where G is basically a constant which is fixed, no matter what the masses are, no matter what the distance between them is, no matter where they are kept in the universe. The value of G is fixed as 6.67 into 10 to the power minus 11 units. And the name of this constant is universal gravitation constant. Why is it known as universal? Because you go anywhere in the universe, the value of G is going to be constant. It is universal, it is fixed. That is why universal gravitation constant is the name. So please note it down. If there is any doubt, you ask it to me. Lakshay?
No, ma'am.
Are you clear? Everything you are able to understand?
Yes, ma'am.
Okay, fine. So please note it down, whatever is written in the white, and go sequentially.
Ma'am.
Done?
Ma'am, I wanted to ask in the second
Okay.
G is a
Which
constant. G is a constant whose value doesn't depend on what is the
masses?
factor last word?
Masses, distance between objects, medium in which the object is Kept. Medium in which object is kept should be written here. Wait.
Thank you, ma'am.
Okay.
Written, ma'am.
Yes. Are you
Done.
done?
Yeah,
Okay.
ma'am, done.
So as I
Yes,
told
ma'am.
you that how many points? One, that is the name we know. We know that it is a constant whose value is this much. We also know that it is fixed. It does not depend upon the masses, the distance between objects and the medium. The only thing which we need to know is what is the unit of this constant. So we are going to know the unit. As I've told you that whenever you need to find the unit of something, all you need to know is the formula of that thing. Okay. So G. In order to calculate the unit of G, I need to find out its formula. So its formula can be found out by cross multiplication and by taking everything on the other side of equal to and keeping G on one side. So I've kept G on one side. I've sent R square here. So F into R square, and this is in the numerator. So on the other side of equal to, if it goes, it will be in the denominator. So F into R square divided by M1, M2. The unit of force is Newton. The unit of R square, R is basically distance. So the SI unit of distance is meter. So Newton meter square divided by SI unit of mass is kg. So kg into kg means kg square. So unit of G is equal to Newton meter square per kg square. So this is the unit of that constant, which means if you need to completely describe G, this is how you do it. 6.67 into 10 to the power minus 11 Newton meter square per kg square. Got it, guys?
Yes, ma'am.
Noted down.
Yes, ma'am.
Noted,
Yes,
noted.
ma'am.
Ma'am, we can even write it as kg raised to minus 2, right?
Yes, yes, you can also write it like 6.67 into 10 to the power minus 11 Newton meter square. And since this thing is in the denominator, if you bring it to the numerator, you have to make the power negative. So Newton meter square kg to the power minus 2. Done, guys?
Yes, ma'am.
Okay.
Ma'am, 1 second, ma'am, 1 second.
Okay.
Yeah, I'm done.
Fine. Just a second. Okay, so we again come to the formula. F is equal to G m1 m2 by r square is the final formula that we have. Now let's apply this formula. Okay, so I'm giving you one example where I've taken two masses of 1 kg each. Okay, the masses are of 1 kg each, and we have to I have kept in the example, I myself have kept the distance between them is equal to 1 meter square. And I want you guys to use this formula and calculate the force of gravitation which exists. So all you need to do is you need to put the value of m1 as 1 kg, m2 as 1 kg, and the distance between them is 1 meter, right? So 1 meter, so 1 square will be there. So I've put the values here, 1 into 1, 1 divided by 1, everything becomes 1 only. So it means that here the value of the force which exists between two masses having 1 kg mass each and kept at a distance of 1 meter is coming out to be G. If we evaluate the value, or if we look carefully at the value of G, then the value of G is 6.67 into 10 to the power minus 11. By seeing the power which is raised to 10, you can evaluate that this number is very, very smaller than 1. Can you guys see? This is 0.000000, 11 digits before, like 10 zeros before 667. This much. This is how small the value of G is. 6.67 into 10 to the power minus 11. So which means a very small amount of force exists between two masses, both of them being very small. If both of them are very small, then there is a very little force which exists between them. You think about it, 6.67 into 10 to the power minus 11. This is very small force, and this is such a small force that we cannot even see, or we cannot even analyze these kind of small forces. So that is why if someone asks you that why two bodies which are kept, or let's say why things which are kept near you are not attracted by you, that is because my mass and the object, let's say the chair which is kept in front of me, I am not attracting the chair because the mass of that chair and the mass and my mass are very small. So that is why force is not coming out to be significantly big. So that is why it is not making any impact. But there exists an attractive force between both the chair as well as me. So that is why this is the answer, that why I can't see any object getting attracted towards me which is kept near me. So this is the reason. The force exists. The magnitude is also given by this formula, but we cannot notice that force because that force is as small as 6.67 into 10 to the power minus 11 Newton. I mean, the magnitude will vary, but the force is going to be of this order, which is going to be significantly small. Is this clear? That why two objects kept near each other do not generally seem to attract each other? I hope this is clear. This was very easy, guys. No? Not even one yes.
Oh, ma'am, I was on mute. I said yes.
Okay, fine. What about others? What about Rehat?
Ma'am, it's kind of clear. Can just
Kind of.
once
What
more
is the
explain?
confusion? Okay, talk about it. So I'll understand where you are lacking behind. So tell me.
Ma'am, I understood till the
This formula you understood,
equals
F
to
is equal to
G
Gm1
into
M2 by
1
R square.
kg. Yeah, that
This you
I
want.
understood, ma'am.
So I told you that there is an example in which I need you to calculate the mass, and I need you to calculate the force of gravitation which exists between two masses having 1 kg mass each. This is also a 1 kg. This is also a 1 kg. I want you to calculate the force of gravitation which exists between them if the distance between them is kept to be 1 meter. So all of these values are given to you in the question. So if these values are given, all you are going to do is you are going to put the value of G, M1, M2 and R square. You have put all the values and finally you are getting the force. See, 1 into 1 is 1, 1 by 1 also 1. So all of this is gone. Force comes out to be equal to G. What is the value of G? Just now I told you that the value of G is 6.67 into 10 to the power minus 11. So the magnitude of force is coming out to be this small. Are you able to analyze how small the force is? Because 10 to the power minus 11, how much is it? 0.000000. Let me write. This small the force is going to be. Now, do you think this is significant? Do you think this is something which we can analyze with our eyes? No, right?
No,
Because
ma'am.
this force is very small. It exists. It is there. The bodies are attracting each other. These 1 kg masses are attracting each other, but we can't see it because the magnitude of the mass is very small. So, which means when both the masses which are involved in attraction, if both these bodies are of very small mass, then the force is not going to be significantly big for us to analyze it, or for us to be able to see it. So that is why we generally do not see two bodies attracting each other which are kept close to each other. Got it, guys?
Yes, ma'am. Understood.
Fine. Now from here we can also like get the definition of G. If someone says that, okay, define what is universal gravitation constant, how are you going to define? You only know the value of it. You can right now, with all that you know, you can only write that, okay, the value of G is 6.67 and its unit is this and it doesn't change, etc., etc. But definition means to define that thing, right? So from here we can define universal gravitation constant. How can I define? See, I can say that numerically the value of G is equal to the force which exists between two 1 kg masses which are separated by a distance of 1 meter, right? Because here we saw that the force came out to be equal to G, came out to be equal to the value of G. In which case? In the case where the masses were of 1 kg and the distance between them was 1 meter. So we can say that you can understand it like this, that universal gravitation constant is basically the force which exists between two 1 kg masses which are 1 meter apart from each other. So this is the definition. Universal gravitation constant is numerically equal to, see, gravitation constant is not force, but it is numerically equal. Just like in the first chapter, I told you that distance and displacement cannot be equal. Distance, only the values, only the magnitude of distance and displacement can be equal, because distance is scalar, displacement is vector. Both are different physical quantities, both of them cannot be equal. So only the magnitude of them can be equal. So similarly here also I'm talking about the same thing, that is universal gravitation constant is not equal to force. It, see, this is other quantity, this is other physical quantity, but they are numerically equal. In which case? In the case where the masses are of 1 kg and the distance between them exists equal to 1 meter. Guys, did you understand this much? Please tell me if you did.
Yes,
Yes, ma'am.
ma'am.
Understood.
Yes.
So write it down, write down the definition and this example. Guys, are we done?
Yes, ma'am, done.
Okay.
Done.
Ma'am.
So the next thing which we are going to do here
Done,
is
ma'am.
so only this thing which I just now discussed, that why the force is not visible between two small objects. So that is what is written here, that since the value of force acting between these two objects of 1 kg mass kept at 1 meter distance is so small, that's why we don't see these bodies moving towards each other because of the attractive force which exists between them, because the force is significantly small. It is insignificant basically. So that is why the bodies do not move towards each other. So this is the reason. We are done with this. So now, okay, if there
Can
are,
we write that down? The previous
yes, sure, sure. Wait a second.
Yeah. Done, ma'am.
Okay, so moving ahead, see, just now we saw that, okay, if the masses are very small, if both of the masses are 1 kg 1 kg or small, then the force is not going to be significant. What if one of the body is small, let's say 1 kg 2 kg 3 kg, but one of the body is very large? Let's say we take the other body as earth. Now compared to 1 kg 2 kg 20 kg 30 kg, compared to these values, the mass of earth is enormous, right? So which means earth or the equivalent bodies like earth, moon, or any other
Jaja.
planet
Your slide.
is going to act. What happened, guys?
Ma'am, did you change your slide? Oh.
No, just now I did not do anything. What happened? Are you able to see?
Yeah, ma'am. That
I'm
1
using
kg
yes,
you are. Okay.
Okay, so I was saying that, okay, when both the masses are small, we are not able to observe the force. But when one of the masses,
वही तो कह रहा हूँ जाओ
guys, what is happening?
I don't know. Someone's back.
Lakshay, what happened? Okay, so if you're talking to someone at home, please turn your mic off, okay? So I was saying that when two bodies are small, then in that case, force is not absorbed. But what if one of the body is large and the other body is small? That is, we are taking one of the body of the size of Earth. Let's say we can take Earth, Moon, Sun. These are bigger bodies. These are large bodies. Whereas when we talk about small masses, 1 kg, 20 kg, 30 kg, even 100 kg, compared to the mass of Earth is going to be small. So we are going to take one small body, one large body, and we are going to say what the value of force comes out to be. Definitely the force of gravitation is going to come greater than what it came in this case. In this case, both the bodies were small. So that is why a small value of force came out. Let's see what value of force comes out when we are taking Earth, we are considering Earth and 1 kg mass, okay? So here I am calculating the force of gravitation using F is equal to m1 m2 by r square only. And I want to calculate the force which exists between Earth and the 1 kg mass. So guys, can you help me with it? If I tell you the value of mass of Earth, mass of the body, that is 1 kg. So two bodies are involved. I am writing the details here in the red. That is, one mass is of 1 kg. Other mass is of, that is the mass of Earth is given to be, let's say 6 into 10 to the power 24 kgs. Okay. And the distance between the bodies, That is the distance between the center of the body and the center of the earth. This distance is given to you. That is, R is given to you as 6.4 into 10 to the power 3 kilometer. You're supposed to calculate the force which exists between them. You can use the calculator and tell me what the value of F comes out to be. Okay, guys? But in the paper, obviously, you don't have to use the calculator. But for now, you can. And quickly tell me what the value of force is which exists between the Earth and this 1 kg mass. Can you tell me the force of attraction with which these two bodies attract each other? Giving you 2 minutes. Quickly tell me.
Ma'am,
Yes.
I use the calculator.
Hmm.
I don't know if the answer is right. There are too many decimal points. 1.46484375.
First of all, tell me, no, this big value is not going to come. First of all, tell me, did you use the value of G? G also has a factor of 10 to the power minus 11. And don't forget that this value is in kilometer. We have to put the values in SI unit so that G can come out in SI unit, so that force can come out in Newton, right?
Oh, yeah.
So that you have to do. Let's see. As I told you that one body is mass, one body is your earth, and other body is 1 kg. This 1 kg
Ma'am,
object.
how big is the value?
M1 very small. M1 is 1 kg. M2 is 6 into 10 to the power 24 kgs. The distance between them. See, guys, this value of R is given to be 6.4 into 10 to the power 3 kilometers, right? So this
Yeah.
value of R which I have given you is nothing but the radius of the uh, earth. Now you
Yeah.
will say that, ma'am, if this is the radius of the earth, then why have you said that this is the distance between, this is the center to center distance between these two objects? There is a difference, right? This is the radius. Radius is this much long only. I need to find out R is what? R is basically the distance between the centers of the two objects. Then why did you say that this R is equal to this much distance? Because, guys, let's say this mass is there, okay? You are dropping it, let's say, from a height of 10 meters. Do you think 10 meter is significant in front of the radius of the earth? Radius of the earth is this much. That is 6,400 kilometers. In front of 6,400 kilometers, this 10 meter, whatever distance the small object is far away from the earth's surface, that distance, that height of the object is going to be insignificant. So that is why whenever you are using this formula, F is equal to gm1 m2 by r square, and when, let's say, there is a small body and there is a big body involved, then in that case, this distance, like, compared to the radius of the bigger body, this distance which is there, this distance is going to be insignificant, okay? Because this is very small. 10 meter is very small as compared to 6400 kilometers. So that is why even the radius of earth will do. So we have approximated the value, but this approximation is not going to, affect the answer. So that is why the radius here will also do. But keep in mind that this is the distance between the objects. Did you guys understand what I'm trying to say?
Yes, ma'am.
Sure.
Yeah, ma'am.
Okay. So how to calculate force? Just put the values, yeah. G. So G is 6.67 into 10 to the power minus 11, right? And M1 is 1 kg.
To 6 into
M2 is 6.4, sorry, M2 is 6 into 10 to the power 24. So G M1 M2 divided by R square. What is the value of R square? R square means, see, first of all, let's convert it into meters. Okay, how to convert it into meter? We know that 1 kilometer is equal to 1000 meters. So I'm going to multiply it by 1000. So I'll get 6.4 into 10 to the power 6. Okay, so 6.4 into 10 to the power 6, and that too should be squared. Okay, so the final value will be 6.67 into 6 divided by 6.4 square. Let's just see the powers of 10. Let's just solve them. Okay, so here in the denominator we have 10 to the power 6 into 2, so 10 to the power 12 will be here. In the numerator you have 10 to the power minus 11, and you have 10 to the power 24, right? How to solve it, guys? Do you know how to solve 10 to the power minus 11 into 10 to the power 24 divided by 10 to the power 12? Tell me quickly. When
come to minus 11 plus 24.
yes, the powers will get added for the numbers
Yeah.
of multiplication. That is,
Yeah.
here you can see that the,
And then
when you add minus 11 and 24, you will get 13. So 10 to the power
13.
13 divided by 10 to the power 12.
and 14 minus 12 because it's divided.
10 to the power 1, right? So what are we left with? We are left with 6.67 into 6 into 10 divided by 6.4 square. Please calculate it using the calculator. What is the value coming out to be?
Ma'am, in exams, such complicated questions won't be asked. Or
No, they won't come. Even if they are giving you bigger values, those will be easily, you will find the common factor, and those will be easily cancelled out. So don't worry about the calculation. What is the value, guys? Quickly.
Yeah, ma'am.
You have to use a calculator and tell me what is the force coming out to be. Arushi, why are answers not coming today? What happened?
Ma'am, I am giving. I'm just calculating it.
Okay.
But
By the
is
way,
it
you can use calculator as well.
I'm 9.77.
9.77, which is approximately like 9 yes, so 9.8 we can take.
Yeah.
So which means the value of force is coming out to be 9.8 newtons,
Yeah.
as compared to the previous value of force, which was 6.67 into 10 to the power minus 11, right? When the masses were of 1 kg and the distance between them was 1 meter. In that case, the force was coming out to be this less. But when we increase the size of one of the bodies out of the two bodies, we saw that, okay, the value of the force now is significant. See, 10 Newton force is significant. That is why you can see that whenever a ball is thrown from a certain height, it gets attracted towards the earth, and you are able to note that motion. Why are you able to note that motion? Because the force is significant. If the force is significant, you are going to see the effect of that force as well. That is, the ball is going to move downwards, and it is going to, like, since the force is in the direction of, see, just observe the direction according to what I have given you the definition. So just a second. Wait. What did I tell you about the direction of force? I told you that the force is going to act in the direction of line joining the centers. So this is the line joining the centers, right? If I ask you, where is the force going to act for this? Since the earth is attracting this body, so the force for this body is going to act downwards, right? So this force of 9.8 Newton is acting in downward direction on this smaller body. Similarly, as a result of action reaction, this is the action, that is, earth is attracting it with a force of 9.8 Newton. So which means that the ball is also going to attract earth with a force of 9.8 Newton.
Okay, ma'am.
Is this clear? Is this calculation and the direction clear?
Yes,
Also,
ma'am.
you know, when the
Yes, ma'am.
ball is dropped, the force acts in the downward direction, and that is equal to like whatever direction, whatever method of direction I told you how to calculate it, how to see the direction. So you either use that logic of finding the direction of force, or you can also apply logic and see, okay, when the ball is dropped, the force acts in the downward direction only. So
Ma'am,
9.8 Newton force is acting.
ma'am, I have a question.
Yes.
Ma'am, so basically, Earth is pulling the object. There's attraction between the Earth and the object,
Yes.
right?
Yes. Yes.
So when the object, like, suppose on a table of, suppose the ball falls on a table. So is it because of the Earth's gravitational pull, or is it because of the table? Like,
See, if you are holding a ball above a table and if you drop it,
yeah,
then that drop or that fall is going to be because of the Earth's attraction. Why? Because if you see, the logic is correct. You say that, okay, if every object in the universe is attracting every other object, it means that the ball is going to be attracted by the table, right? But
yeah,
as we can see that the table and the ball both are small masses, so that is why the force because of the table, the attractive force because of the table on the ball is going to be very small, and the significant force because of which the ball is able to move downwards, that would be because of the Earth's attractive force, because Earth is a bigger body and significant force of attraction will come only because of the action of Earth's gravitation force. Okay, the table's force is not going to be significant.
okay, ma'am.
Okay, ma'am, understood.
So have you written it? Should we move forward?
Yeah, ma'am.
Yes, ma'am.
Okay, just a second. Just a second, guys. Rehat, can you hear me, Rehat?
Hello.
Yes.
Sorry, ma'am. I just got disconnected.
Okay, so Rehat, did you hear till the calculation where we
Yeah.
involved
Yes, ma'am.
okay, fine. So which means we have calculated that the force between the ball of 1 kg and the earth is 9.8 newtons. Okay, so please keep it in mind somewhere. Okay, so I don't want you to memorize it, but just keep it in mind that, okay, when earth and 1 kg ball was involved, in that case the force came out to be 9.8 newtons. See, now gradually we are moving. Initially, we had two 1 kg masses, that is two small masses. Then we moved on to one big body and other body was small only still. Now we are going to move on to two big bodies and we are going to observe that how much is the force increasing. Is the value of force going to be very, very greater than this 9.8, or what is the value that we are going to calculate? So please read these conclusions. I think we have done this. The force acting on two small bodies of 1 kg each is 6.67 into 10 to the power minus 11, right? And the force acting between Earth, that is a large body, and a 1 kg body kept at kept few meters apart is 9.8 Newton. Okay, and the force acting between two heavy bodies, we are going to see the force which acts between the moon and the earth, because both of them are big bodies, both of them are part of universe, so it means that both of them are going to exert attractive gravitation force on each other. So we are going to see what that value is, but here it says that force acting between these two bodies is going to be even bigger. By logic, obviously it's going to be even bigger. Initially when two bodies were small, the force was this much. When one body became big, the force was a little greater than what it was initially. Then after that, when two big bodies are involved, obviously the force is going to be even more big, right? So if you want to note them down, note it down, and then we'll move on to the numerical. That is this. So before that, note it down, read it. If you want to write it, okay. If you don't want to write it, take a screenshot. Okay.
Written, ma'am.
Written? Okay. So next up is a numerical, which will involve two big bodies. So here, see if you are able to do the calculation.
Ma'am, in test, like in school test, if this kind of question comes, so will they give the value of constant G?
Arushi, I didn't understand. What are you saying?
Ma'am, like if ma'am, am I audible?
Yes, you are audible.
Ma'am, like if this kind of question comes in for school exams, so
Okay.
will they give the value of this constant G, or like we have
They
to
won't give
memorize
you
it?
the value of G, but see, the value of G is generally 6.67, but they want you to take the approximate value 6.7. So they will specify if they want you to take certain approximate value, otherwise they won't give it to you. So you
Okay,
have to
ma'am.
keep it in mind.
Yeah.
Lakshay, are you able to calculate?
Ma'am, I am able to calculate, but I have a bit difficulty doing that.
Difficulty in the calculation?
Yes, ma'am. Like I don't get it right for the four.
See,
In the
Gm1 M2 by R square, right? So 6.67 into 10 to the power minus 11. 6.67 you don't have to take because it is specified that you have to take 6.7 as the value. So take 6.7. So 6.7, just a second. Into mass, M1. What is the mass of Earth? 6 into 10 to the power 24. 6 into 10 to the power 24 multiplied by the mass of moon, that is 7.4 into 10 to the power 22. So Gm1 M2 divided by R square. So the distance is given to you as 3.84 into 10 to the power 5, but it is in kilometer. So which means you need to convert it into meter by multiplying 1000, and then you have to square it because R square is there in the denominator. Now you have to calculate this force. Okay. So first of all, separate the numbers. Okay. That is 6.7. These values you separate. 6, 7.4, then 3.84 square. This you separate, and after that we are left with 10 to the power minus 11 into 10 to the power 24 into 10 to the power 22 divided by 10 to the power 5 into 10 to the power 3 is 10 to the power 8. If we square it, it is going to become 10 to the power 16. Solve this portion. I hope this is going to be very easy. So solve this first.
Ma'am, into 10 raised to 19.
10 to the power.
19.
See, 10 to the power minus 11 and 10 to the power 22, when we solve it, it will remain 10 to the power 11 because powers get added. So the addition of this and this will give you 10 to the power 11. 10 to the power 24. So 10 to the power 11 into 10 to the power 24 by 10 to the power 16. Solve it. You have to subtract these two. You will be left with 10 to the power 8, right? So 10 to the power 8 means you have to add 8 to 10 to the power 19. This will give you 10 to the power 19, and this, guys, in this case it is tough, but I promise whenever they give you in the paper, the calculation is going to be easier. But for now you can use the calculator because this generally is tough. So these kind of values will not come in the examination, that is for sure, but for now use the calculator. So this approximately is coming out to be 20 point something, right? So the force
Yes,
you will
ma'am.
see
Yes, ma'am.
is enormous. It is very big. 2.17 into 10 to the power 19 Newton. See, in the first case when both of them were small, 6.67 into 10 to the power minus 11 Newton. Negative, the 10 has had negative power on it. So that was very small. Then we got 9.8 Newton, which again is okay, but not very great. Here you can see that the force is very much. So which means that this enormous amount of force exists between moon and the earth, which is responsible for the motion of moon around the sun. Sorry, around the earth, I mean, right?
Ma'am, so
Moon
is
is
this the
orbiting around the earth.
actual?
Yes, it is these are the actual values, right? Mass is also actual, the distance is also actual value, and this is also actual. So which means you have actually calculated the force which exists between earth and the moon. And this is the force which is responsible for the motion of the moon around the earth.
Okay,
Okay,
ma'am.
guys. So here I just want to show you
Ma'am.
that the value of force is increasing as we are increasing the size of the objects. So this is what I wanted to just establish. I hope this is done. So let's move on to the next part, and just a second. See, the next thing is we just now saw that when 1 kg and the earth, this is the last thing I'm going to teach, then we'll end the class, okay? So we saw that when two bodies, that is 1 kg mass and the earth were involved, when we considered these two masses, then there was a force of attraction equal to 9.8 Newton which existed between the earth and the 1 kg mass. Okay, because of this mass I saw that the ball dropped down, that is the ball or the object was moving towards the earth.
Hello.
Ma'am.
Hello, ma'am.
I'll just write in the chat box if she doesn't, she'll see it.
Maybe ma'am got disconnected.
Yeah,
She
she did.
she left. She'll join maybe. Should we wait or should we inform ma'am?
I will just inform Madhumita ma'am. Just a second. If she can contact the teacher.
Okay. Oh, I'll write it on the group.
We should leave, I guess.
Can leave, yeah.
Yeah.
Ma'am just
Bye.
message on the group.